Okay, 9.2 is all about arithmetic sequences. Okay, we're not going to do the sum. We're just going to find t of n. But one thing the chapter doesn't show you that I do. You got an minus 1 by d. And anybody that was taught by me in the junior cert will realise this one. Pay attention. Listen up to this part. This is a sequence where they might say sequence 1 has got 5 matches. Or in game 1, they got this many, or 5 matches. Sequence 2 is 7. Sequence 3 is 9. Okay? This one, slightly different. When you're born, so let's say by years. So when you're born, you're 60 centimeters. And then you're 65 centimeters. This is so far wrong, it's incredible. Okay, so let's say that's when you're born. This is 1 month, 2 months, so on and so forth. Okay, so let's say it's a plant or something. This is what you use when you got time. Okay. Can the sequence start at 0? When you're born, the sequence starts at 0. You're born at 0, unless you're Korean and you're born at 1. Okay? This one, the sequence is first sequence, second sequence, third sequence. Data-wise, this is continuous data, this is discrete data. Actually, probably the timeline. Yeah. But this is 1, 2, 3. Actually, this is going to be discrete as well. But you could, well, no, because this is going to tell you how tall would you be at 0.567 of a month, and you could work that out. So let's look at the two different ones. If I said, what's going to be in sequence 10? Well, A stands for the first one. So A, in this case, is 5, and D is 2. Pretty straightforward. Now t of 10 will be a 5 plus n minus 1, which is going to be 10 minus 1 by 2. That's 5 plus 9 by 2. That's 5 plus 18. That's 23. Okay, everybody's happy with that. Now this t of 10 at 10 months. Well, we're saying in the beginning a is 60. D is 5, so it's 10 by 5. That's 60 plus 50, it's 110 centimeters. Okay, so it's plant or human, very small human there. But this one here refers when it can start at 0. So other examples of that, you put your money into your bank. Okay, day 0, how much do I've got? Yeah, now people will go, but it's day 1, it's my first day. But when you put it in, time has begun at 0. When you wake up in the morning, time has begun at 0. Your day's starting. You haven't done an hour. Yeah? This is now saying sequence 1, sequence 2, sequence 3. Now, in your book, what you're going to come across is this one. You need to know this one as well. I need you to be engaged, that you can get that into your head. Okay? That's the basics. Any mug can work this out. Any mug. So it's not going to be too hard. So I'm just going to show you the other 2, 3 things that you might need to know. Okay? If you're given something like example 3 and you're told t of 4 equals to 6 and 3t2 equals t10. This is not sequence and series anymore. This is algebra. That's a plus n minus 1, which is 4, by d equals to 6. That's a plus 3d equals to 6. What do we expect? I'm expecting the simultaneous equation. That's 3 bracket a plus 2d, it's just one less, equals to a plus 9d. n minus 1 is 9. That's 3a plus 6d equals to a plus 9d. Bring it all to this side. 2a minus 3d equals to 0. And we've got a simultaneous equation. Everybody's happy. That's simple. Simple-ish. You shouldn't really get too confused by that, but some people will, I'm sure. Yeah. I should have T2, so that should be just D. That's 3, that's minus 6D. Now you can divide this by 2 if you want. A minus 3D equals to 0, and you can work from there. Now, if I tell you the first 3 sequences are, well, we'll use example in the book, P plus 2, 2P plus 3, 5P minus 2. Okay? When you're looking at this is T1, T2, T3. Everybody should know that T2 minus T1 is D. This is D, the difference. It's the same as T3 minus T2. So you should expect the same difference. If the difference equals the difference, then we just put in T2 is 2P plus 3 minus P plus 2. This one is 5P minus 2 minus 2P plus 3, fully bracketed. Everybody can work out from this stage. It is example 4 on page 331. Really, 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 really simple. Now, the last one is if they give you something like Tn n plus 1 over 2. Okay? And it says determine if this sequence is arithmetic or not. Yeah, well, T1 is 1 plus 1 over 2. T2, that's 1, is 2 plus 1 over, so that's over 2. That's 3 over 2. T3 is 3 plus 1 over 2. That's 4 over 2. The next one's going to be 5 over 2. So it's going up by half each time. It is arithmetic. Okay? Is it increasing or decreasing? Anybody with half a brain can see that it is increasing. Now, I'm going to put it here. Saying, how do we know it's 100%? Because what if it's T49 or whatever? So if we always want to show that it's arithmetic, we just got Tn plus 1 minus Tn. And that should equal to a constant. The difference should always be constant. So Tn is n plus 1 over 2. And Tn plus 1, here we go, n plus 1 replaces n. And that's all it is. So that's going to be n plus 2 over 2. That's Tn, n plus 1 over 2. So, therefore, Tn plus 1 minus Tn, that's going to be Tn plus 1 is n plus 2 over 2 minus n plus 1 over 2. Put it all over 2. That's n plus 2 minus n plus 1. That's going to give us a half, which is a constant. Therefore, it's arithmetic, and therefore it's increasing. Why is it increasing? Because it's greater than 0. It would be decreasing if it's less than 0. Okay? Please, though, do not forget about the first part. About this. Do not forget about this. Now, I'm not going to give you another video because this work is going to be for today and tomorrow, and I'm also not needed. I don't think you're going to do much work on a Friday of your midterm, so I'm not going to give you stuff for that. Yeah. And I think you have worked pretty well at the moment. So, your question 1 to 13, just get them done on a Thursday and Friday morning, and then you're done and dusted for midterm. Good work, lads.